What are the security differences in OAuth 2.0 grant types? Imagine you're trying to keep your online data safe while allowing apps to access it. OAuth 2.0 helps with that. It offers different ways, called grant types, to give apps permission. But each method has its own security strengths and weaknesses. Let's explore how they compare. First up is the authorization code grant. This method is like giving a key to a trusted messenger who then delivers it to the app. It involves two steps. The user gives permission, and then the app exchanges a temporary code for an access token. This process keeps the token hidden from the browser or user device, making it very secure. Apps with backend servers can store secrets safely and use this flow confidently. Plus, it supports proof key for code exchange, which adds extra protection against interception, especially for mobile or single-page apps. This makes it the safest choice for public clients. Next is the implicit grant. This was designed for apps running entirely in the browser, like single-page applications. It skips the code step and gives the access token directly through the URL. This exposes the token in the browser, making it vulnerable to theft or accidental exposure. Because of this risk, the implicit grant is now deprecated and replaced by the authorization code grant with proof key for code exchange. It requires no client secret but offers weaker security overall. Then there's the client credentials grant. Think of this as a machine talking to another machine. It is used for server-to-server communication where no user is involved. The app authenticates itself with a client ID and secret, then gets an access token. Since no user data is involved, this flow is secure when the client secret is stored safely on the server. It is not suitable for apps that need to access user data directly. The resource owner password credentials grant involves the user sharing their username and password directly with the app. The app then exchanges these credentials for an access token. This method is risky because it exposes sensitive user information to the app, increasing the chance of leaks. It is generally discouraged unless in legacy systems or highly trusted environments. Finally, the refresh token grant allows apps to get new access tokens without asking the user again. It uses a long-lived refresh token that must be stored securely. This improves user experience but requires careful handling to prevent misuse or theft. In summary, the authorization code grant with proof key for code exchange offers the strongest security for user-based flows. It keeps tokens safe by avoiding exposure in browsers. The implicit grant is weaker and now outdated. The client credentials grant is secure for backend services, while the resource owner password credentials grant is risky and best avoided. Refresh tokens help keep users logged in smoothly but need to be protected carefully. For backend development, especially when working with APIs and databases, sticking with the authorization code flow with proof key for code exchange is the best way to keep things secure.